Well, hello there, and welcome back to Inclusive Design 24 2024, brought to you in partnership with our Platinum supporters, Barrier Break and Intopia, and our Gold supporters, Infoaxia and Tetralogical. You can follow us on Mastodon, and if you have any questions for the presenters, you can post them there with the ID24 hashtag, or alternatively, you can use the YouTube chat right here and post your questions. We'll gather the questions for our Q&A at the end of the session. And on that note, a reminder that ID24 is a respectful community, and you can find our code of conduct on the Inclusive Design 24 website. Now, I'm thrilled once again to be joined by my trusty guest host, Lee Dale. Lee, over to you.
Thanks again, Patrick. I'm quite excited to be able to introduce Chancey and Lauren, who will be sharing inclusive methods for co-design between blind and sighted designers. So over to you, Chancey and Lauren.
Thank you so much, Lee. Really excited to be here. So hi, everybody. So Chancey and I today are going to be talking about inclusive methods for co-design between blind and sighted designers. But I am Lauren Race, she, her. I'm an accessibility designer. I work in industry and academia. I got my master's from NYU's Interactive Telecommunications program, or also known as ITP, and I currently teach accessibility design and do grant work at the NYU Ability Project. And that is a research lab that's dedicated to the intersection of disability and technology. And so really my design mission is to remove access barriers through multisensory and co-design methods. I've been working with Chancey for the past 5 years, and we've been developing non-visual art and design techniques at the Andrew High School Braille and Talking Book Library in New York City. So now I'll hand it over to Chancey.
Hey, everybody. I am Chancey Fleet. I am the Assistive Technology Coordinator here at the Andrew Haskell Braille and Talking Book Library, New York Public Library, the very small branch with the very long name. And I curate and manage the accessible technology that we have here in the branch. But more importantly, I'm a tech educator. So it's always been my job and my remit to help library patrons who are blind, low vision, or print disabled achieve their technology goals using all kinds of devices, smartphones, tablets, laptops. And what that means evolves from year to year. Different social networks come and go, different productivity platforms come and go. And one thing that I really love about this job, especially as a blind person myself, is that if there is an area, if there is a discipline within accessible technology that I don't know much about, the library will probably teach me because someone is going to ask. And so what I want to open with today is just a little bit of a professional introduction about how I came to be doing design work at all as a blind person without a background in an academic background in design. So I grew up blind, I'm capital B blind. I am a Braille reader. I am a proficient technology user. I am a self-taught technologist. My degrees are in disability studies and sociology. And so I didn't really have a design background. And when I look back at it now, drawing and design activities would show up from very early in my school career, all the way through college, all the way through professional development, things like staff team building. And when drawing would show up, usually I would be invited to do something else, maybe work on my homework, maybe read a book, or maybe somebody sighted would quote unquote partner with me and do the drawing for me. And the sort of subliminal message that I got from this as a blind person was that drawing is not for me, and maybe design's not for me. So fast forward to 2017. I've been here at the library at that point for about 3 years as a staff member, longer than that as a volunteer. And we're doing what we do, one-on-one technology training, about 150 hours of it a month. And I think I've got most bases covered. And then I get a phone call from someone who shall remain nameless, but who has a C-suite job. They are an executive, they have a team, and they're blind and they're moving to New York City. And they just want something very simple. They want a 5-borough map of New York City so that they can understand the boroughs in New York City and the relationship of the boroughs to the waterways. And I started to think to myself, I don't like this. I have a reference question, worse, an accessible technology reference question that I have no idea how to answer. And I started reflecting on why that might be. When any blind person, when any sighted person can come to a library and print basically any map they want if they don't just pull it up on their phone or their tablet, why is this such a hard thing for blind and low vision folks? And I came to realize that although I know that technology for making tactile graphics, which we'll discuss in a few minutes, has been around for decades and is fairly well understood, it's usually on the wrong side of an institutional locked door. As I continued in this work, a lot of people would say to me, oh yes, we had a swell form machine, we had an embosser at my school, but I wasn't allowed to touch it. So tactile graphics and graphics education often come from sighted people who are designing graphics for blind people. And it's often in the context of schools and textbooks where there are some regulations that require tactile graphics. We don't have a lot of requirements for tactile graphics yet. And so the problem is that most blind people don't have a straight path from their curiosity about a graphic to having that graphic under their fingertips because they don't have access to the means of production. So I launched the Dimensions Project, which is a project of the New York Public Library's Innovation Grant, which is a program for staff who think that they have an idea. And we launched the Dimensions Project so that blind people, sighted people, and anyone in between would be able to come to the library and create tactile graphics, i.e. raised line drawings in a variety of formats. And we endeavored to find the most accessible software that we could and hardware that we could. And so people can come in by appointment and work with us 6 days a week. Everything here is free except for the cost of paper and filament, just as we do for sighted library patrons. And we emphasize hardware and software that's as accessible as possible. And when something's not fully accessible, we emphasize workflows that will make it work anyway. And we don't require any design experience. And so individuals come in, family members, educators that might want to make things like graphs, or mobility instructors that want to make a diagram of an intersection, but also museums and culture workers who want to make didactics, who want to make art pieces, all kinds of things. People have come in to make tactile fingerprints and footprints for a blind forensic camp. That was one of my favorites. I'd never seen a fingerprint before. So fast forward a little bit more to 2022. We have this lab. It's been cooking for a few years and entered the Astro Access project. So there's a little bit of backstory here, and there's an image here, which is two folks on the Astro Access plane with image credit from Astro Access. So Astro Access is a nonprofit cooperative of people with and without disabilities who want to investigate what happens when, not if, but when, we have disabled passengers and disabled crew members in space. Their catchphrase is, if we can make space accessible, we can make any space accessible. And in this instance, there were 3 members of crew, 2 flight crew members, Lindsay Yazzolino of Houston and Sherry Wells-Jensen of Dr. Sherry Wells-Jensen of Ohio, and ground crew member Danielle Montour, at that time of New York. And they wanted to create some tactile orientation tiles to make navigation on the zero gravity parabolic craft accessible. When you are in zero-G flight, you don't experience gravity, right? But when the parabolic flight is done, when the parabola is done, when gravity comes back, it's really important to know where gravity will be when it returns, because you've got to position your body in such a way that you land safely and comfortably where you're supposed to, and you don't subject your body to gravity in a way that's going to hurt you. It's really important. In addition to that, of course, we know it's important to know where those emergency exits are, if you've ever heard the lecture, as you fly on a regular plane. And we also need to know where emergency supplies are. So that was the goal, to create tactile orientation tiles that might also have a visual element for sighted folks, but first and foremost, could be read by blind folks, and could be read quickly and with a high degree of accuracy, whether or not you know what your orientation is, probably with one hand because you're bebopping around in zero gravity, and so you're using your other hand to hold on to something so you don't go drifting. So Why did Astro Access choose this of all possible libraries to come and work on this problem? We think that we are the only lab who are free and open to the public. We don't have any prior expectation of knowledge. We don't do any kind of gatekeeping. You don't even need to show us your library card. So if you're coming from New York, outside New York, that's okay. NYPL has a worldwide audience. The other reason is that this was the only place that the team was aware of where blind crew members could have the expectation that they would be able to largely address this design challenge themselves, despite knowing that design is a challenge sometimes for blind folks, and despite not having a strong background in design. Here we move on to a shot of the library. It's the exterior of the Andrew Haskell Braille and Talking Book Library with image credit from Flatiron Nomad. We are in the first 2 stories of a tall building, and we have some other non-public floors hidden away that have exciting things like an audiobook studio. That's a different presentation for a different day. So Astro Access budgeted a day to spend here. And the first thing that I did, even before they came in, was to talk to them about the landscape of accessible design and what they could expect. And what you can expect as a blind person trying to enter design is quite a bit of friction, actually. If you think about popular computer-assisted designing and drawing programs, I'll name a few: Inkscape, Illustrator, Procreate, CorelDRAW, Microsoft Paint. All of them have 2 major challenges when it comes to accessibility. One of them, individual design companies can't really help. We want a tangible, tactile canvas, lines that change that we can feel by touch, and that's coming. There's a device called the Graffiti. There's a device called the Monarch. They are entering the market now, but they're not cheap. They're $15,000 and up. And so that's not an option for everyone at all times. And those devices do have some limitations. But what's really a little bit suboptimal is that even the menus and dialogues and parametric things that you can do with these programs are not accessible to screen reader users. So I might say to myself, well, I know that I won't be able to touch my drawing in this given design program, but maybe at least I can bring the file in, I know what it is, and then maybe at least I can rotate it, change the thresholding, get it into black and white maybe, and rescale it. I really cannot, because none of these programs have proper classing and labeling of elements that screen readers can understand. I think that there's a widespread assumption in the industry that blind people are not designers, that if anything, blind people are design recipients. And this is an area where accessibility work, really basic accessibility work, has often not been done. So another thing to keep in mind when you're a blind person looking to explore design is that if you don't work full-time in development or design, you might not know what the landscape is. You might try a CAD program and think that the problem is you. And so what we try to do at the library is give people a game plan. And here's the game plan that we followed. You can see on this slide the design team sitting around with a table, and you'll notice that we don't have any computer. Well, there's a laptop on the table, but it's not the star of the show. There are drawing boards, paper, and a laptop here in this picture. And so one thing that everybody can do, regardless of the state of computer-assisted drawing programs, is everybody can draw by hand. We hand out sensational blackboards. You can check them out at sensationalbooks.com. These are rubber surfaces layered on top of plastic surfaces. So just like a very simple drawing board, it's $50. If you don't have $50, you can buy a $3 silicone placemat at Walmart, put it on a table, and get the same basic effect. You draw with a ballpoint pen, but you draw firmly. You draw with less gentleness and more pressure, and it raises a tactile line. So everybody who's sighted can see the ink, and everybody who's blind can feel the line. And it is dirt cheap because you can use any old big ballpoint pen, you can use any old copy paper, and this way we can experiment and iterate. So the first thing that I asked folks to do on the crew was to practice drawing lines, get comfortable with their line weight, get comfortable using the hand that they're not drawing with to sort of monitor the drawing and feel the lines as they're popping up. get everybody fluent with that. And that was like an aha moment for at least one person on the team who had not been drawing since they were a child. And that's an experience that we hear about a lot. And we do have these sensational blackboards, by the way, to check out with your New York Public Library card. So that's the hand drawing part. And everybody on the ground crew pretty quickly came up with some ideas about how the direction of gravity should look and how emergency exits should look. And Lauren's going to tell you much more about the design process. But we don't want to put up on the $1 million flight our hand-drawn little drawings. We need digital drawing. Because digital drawing allows precision and sharing and revision, revisability. So the second part in our flow was working with a sighted designer, in this case, Lauren, to do some active allyship and be the person entering designs into CAD. So Lauren was able to take a look at iterations once the group had consensus that they wanted to pass an iteration forward and try digitizing it. And Lauren will tell you about how she did that. So in the meantime, we've got another slide here. The sensational blackboard is the star in this one. It's got a tactile drawing of a house, and that comes from the Exceptional Teaching organization, and a drawing film board, which is another similar product that has a butterfly on it. So what are the options for tactile graphics once you go digital? I'm going to walk you through a few of them. We have graphics embossing. Here in my hand, I have my notes. They are Braille paper that came out of a Braille embosser, and that same Braille embosser can punch up to 100 dots per inch, which approaches the edge of tactile resolution, tactile perception. This is pretty affordable once you get the embosser, and embossers aren't cheap. We're talking $1,500 to $6,000. But once you do that, the cost of paper is not that painful ongoing. The Braille is really crisp. The lines are really crisp and clear. That's what's good about it. What might not be so good, it provides white on white embossing. Unless you have a special embosser that also does ink, it's not going to be high contrast, so it's not great necessarily for mixed teams. And it is going to feel a little pixelated, not very, because again, tactile perception is not the same as visual perception. It's not so pixelated that it's distracting, but a little pixely. So maybe it's not going to be the most circular circles in the world, for example. You might feel a little pixels there. Another method that we offer at the library is thermoform. So in thermoform, we use something analog like a collage, mixed media, tin embossment, and we fit a plastic sheet over it, and we apply heat and a vacuum seal to make a perfect thermoform copy of whatever's underneath. That is really great for making really deep and textured and compelling designs. Great for people that want to do accessible design, but they don't want to mess with the computer. It's not what we used in this case because we wanted to be able to make revisions, and thermoform is not really for making revisions. There's 3D printing. So if you want to build a model of something and you need a lot of deep layering, like maybe a topographical map, you might use 3D printing, or you might use 3D printing so that you could touch something from every angle. I was showing around earlier a little tiny Martin Luther King Jr. Memorial Monument. And if you go up to the monument in DC and you reach out, you might be able to touch the base of it, but you won't be able to really touch the whole monument unless you're giant. So 3D printing can help you experience something at a more appropriate scale. So it's not what we went for in this case. What we went for in making our digital drafts is a technology called Swellform. So Swellform uses patented microcapsule paper that contains alcohol, and we run that through a laser jet printer that disperses carbon-based ink, or we can use a carbon-based marker and draw on it analog if we'd rather. And then we're going to run it through a kind of a little easy bake oven looking machine that has a lamp inside, and the heat that the lamp produces make the alcohol in the microcapsule paper and the carbon in the ink react and swell up. So we're going to have a bold visual and also bold and nuanced textures without pixelation. Braille may not be quite as crisp, but the textures are bold and beautiful, and it's multimodal because we can use grayscale ink. So the images on this side show what we've talked about: an embossed moon, set of moon phases from You Can Do Astronomy, a thermoform tactile graphic of a rabbit and a frog from Kagawa, a swell form graphic of a house from American Thermoform, and a 3D printed map from Touch Mapper. So we presented these options, and then we did present the option of having the final panels made offsite by a sign maker, a UV printer, who got involved at the end. So that's my story now. At this point, I'm going to shift over to Lauren, who's going to tell you all about the design process.
Thanks, Chancey. Okay, so I'm going to talk about how we did this and then what we learned, so you can consider it for your own inclusive design process. So what we did was we leveraged our team's existing design partnership to experiment with a 3-step design process. We already knew each other. We've been working together at the library for a while, so it was kind of a natural for us to fall into this design brief together. So what we did for step 1 is we used drawing boards for low fidelity sketching, like Chancey mentioned, the sensational blackboards. And then we leveraged the sighted designer, which was myself, to render the sketches in vector using Illustrator because it was inaccessible with screen readers at the time. And then the 3rd step is producing microcapsule prints for high fidelity evaluation with the team. So we used drawing boards and drawing film, and what was so great about these tools is that they offered this immediate pen to paper access, which enabled the group to produce a lot of ideas as quickly as they could be drawn and touched. We actually had to make a symbol set from scratch because there were no broadly used tactile symbols that addressed our use case. This had not been done before, so we had to start from the beginning. And these drawing boards really enabled rapid design decision-making because the group could pass them around to deliberate sizing, line weight, shapes, and proximity. And so the images on this slide show a drawing film board with an early iteration of the Astro Access symbols with image credit from the presenters. And so then after that, the team needed to print the sketches on the swell form or microcapsule paper. And what that meant was rendering the sketches in vector so they could be printed before being run through the fuser. And this kind of gives us those pixel perfect images using CAD software like Illustrator. And so the group decided to leverage me, the sighted designer, to note each symbol's like general shape and then measure the dimensions with a caliper. And then what I did was I would trace the sketches in Illustrator and I would input the caliper measurements. So just basically refining them. The image on this slide shows a vector version of the early iteration of the Astro Access symbols with image credit from the presenters. And then finally, we printed the vectors from Illustrator on microcapsule paper, and we ran them through that fuser. And then what would happen was the blind designers would review each print and they would give me feedback. And so what I would do is go back and implement that feedback from them. And it took our team 9 iterations to get a readable set of symbols that the entire team was on board with. And I think this is a really good reminder of just how much time and craft it takes to design something tactile that's readable and usable. You can't just put any image through a microcapsule fuser like the swell form and expect it to be readable. You need to give it the time and attention it needs to be designed for touch. So after we did that, we printed the microcapsule copies and we delivered them to the Astro Access team. So the image on this slide shows a microcapsule print of the early iteration of the Astro Access symbols next to some drawing film sketches with image credit from the presenters. So like I said, tactile design is so different from visual design because tactile acuity is actually about 100 to 200 pixels per inch, while from about like 12 inches away, visual acuity is 720 pixels per inch. So designing for touch is very different for designing for the eye. And I think that is a huge gap in skill set in current design curricula. So for inclusive design, I want to go over the tactile design standards that our team used so you can consider incorporating them into your own inclusive design practice and expand your own knowledge. So the first standard that we used is to put a triple slash in the upper right-hand corner of the page. You can also cut off the upper right-hand corner as an alternative. For any New York subway riders on the call, the upper right-hand corner of the old Metro card is cut off. And this is so that the rider knows how to hold the card when they swipe it through the machine. This is a tactile graphics orientation standard that's been around for a while, and it helps the reader know which way to hold the page. So the image on this slide shows a horizontal piece of paper with a slash in the upper right-hand corner. The second standard is generally using one graphic per page. And the reason for this is because when you scale something down, you're losing tactile information and detail. So it's much better to separate two graphics on two separate pages. The images on this slide show a crossed out page of two ducks side by side, and then a green check mark next to one duck that's scaled to fit the entire page. And then the third standard is that hollow is more discernible than solid. And this is because when you trace a solid shape with your fingers, it doesn't have an outline. So there's no guide for your fingers to trace around the shape. So it can end up feeling like less crisp and distinct and harder to discern. So when you make your shapes hollow, there's this nice guide for your fingers to follow and build a mental model of that shape. The images on this slide show a crossed out solid duck and then a green check mark next to an outline of a duck. And then the fourth standard is to use about a 1/4 inch between elements. This is for tactile breathing room, right? In design, we often talk about white space. White space applies to tactile acuity as well. If you put elements too close together, they feel like they're merging into one complex shape. So being able to trace around each shape independently provides more tactile clarity. So give your design elements some white space. About a 1/4 inch is best for tactile acuity. So the images on this slide show a crossed out duck with the water line right up against its stomach, merging into one shape, and then a green check mark next to a duck with the water line moved about a 1/4 inch away from its stomach. All right, so what we learned. I wanted to discuss some of the challenges that we ran into in case you're thinking of kicking off your own co-design process. And maybe you can learn from some of the things that we wish we had done a little bit differently. So the first challenge was that the 3-step process worked overall, but we ran into a significant issue with co-designing with the sighted designer and myself. There was this workflow bottleneck effect between the 4 blind designers and myself. The 4 blind designers were interrupted because they were waiting for their drawings to be converted to vector by me. So I was sitting there like trying to go as fast as I can. And that was really frustrating because folks wanted to stay in that creative flow and they were stuck waiting on this one person. Not to mention, without a foundation of trust, there was always the risk that myself, as the sighted designer, could take control of the design process. And what that looks like is doing more than just image transformation in Illustrator. It can look like making assumptions about what the blind designers want, embedding ableism in design decisions. It can look like moving from a supporting to a leading role within a blind-led design space. And our team was able to prevent this from happening by actively agreeing to correct each other on ableist assumptions and actions without defensiveness. So maybe you're wondering, okay, how do I build a foundation of trust in my team with blind and sighted designers? Chancey and I have deliberated this for a while, and we've pared it down to 5 things to consider that have worked really well for us at the library. The first is committing to building prolific connections in communities of disability. The second thing is consistently and reliably showing up for one another every time. The third thing is having a willingness to learn from and correct ableist actions and assumptions without defensiveness. The fourth thing is centering non-visual techniques and tactile design as critical and valuable skills. And then the fifth is having a neutral meeting space, like the library, where everyone has equal input. So the second challenge that we ran into was that remote work really slowed down our design process because design decisions were made over email over the course of days rather than in person over the course of minutes. So the blind designers still had to print the designs and then run them through the swell form fuser to give me feedback, which took time and money. Also, with the tactile nature of our design process, we had to begin relying on visual description rather than just simply touching the designs in person. In terms of opportunities, so things that went well, right? The awesome news is that our team was able to deliver readable tactile graphics on time and on budget. And Sherry Wells Jensen at Astor Access told us they were used successfully on a zero gravity flight with blind flyers through Astor Access. And with this 3-step process that we used, it ensured that blind designers were in a central role and they owned every iteration, while myself, as the sighted designer, I remained in a supporting role of image transformation in Illustrator. Because the blind designers had this tactile graphic expertise, I could focus on accurately rendering the symbols, but also without suggesting changes. Again, being more of a support to the group rather than controlling design decisions. The second opportunity was that drawing film and drawing boards were a hit. They were really fast ways of communicating spatial information non-visually. And like Chancey says, if you ever come down to the library, you can check one out and try it for yourself. So recommendations. So our experience led to generating some recommendations as motivation for blind and allied community members who want to engage in accessible design practices, technologists who want to center blind people in the design and development process, and researchers who are interested in the intersection of disability justice and design. So as a team, we advocate for creating inclusive workflows by centering disabled designers. Sighted designers really need to understand when it's time for a supporting role over a central role. They should be supporting non-visual efforts, but not leading them, to avoid that sighted bias and design saviorism. How our team defines design saviorism is that it is seeking praise while trying to fix something that isn't broken. And I will stress that design saviorism is not good design, because it means that the designer didn't take the time to deeply understand whether or not the design process problem even exists, or if it's their own bias talking. The second recommendation is matching non-visual design tools to your team's needs. The tools that are available are using a screen reader, accessible design tool like Tactile View. Tactile View is definitely expensive. It's almost $500, but it is compatible with a range of Braille embossers, and it's fully accessible with screen readers and keyboards. You can use it to choose pre-made graphics. You can convert images to vector using filter and retouching. You can design from scratch using tools or math. Your next option is co-designing with a sighted designer. You can partner with a sighted designer if you want to iterate rapidly and your team is new to digital design. And then the third is hand coding SVGs, right? If your team is open to programming, it is great. It is free. It gives full creative control to blind designers, and text editors are screen reader accessible. We found that you can use drawing boards and tactile graph paper in the sketching phase of the design process. And you can use this method to understand shape sizing and positioning and actually plot out how the drawing will exist in the SVG coordinate space. And finally, you need to understand the access trade-offs in design tools. Some are more expensive and high fidelity than others, and it's important to understand that there's not one perfect solution, since every team has different preferences. For example, drawing boards and films are great, but their output is not as durable and they're more low fidelity. So once you produce them, they degrade with time. Partnering with a sighted designer obviously had issues with our team, right? There was that bottleneck effect that happened, and that designer could potentially take control. And then Tactile View is expensive. We do have things like Inkscape, which are free for vector design, but you need plugins to support menu-driven design for screen reader access. And then finally, SVGs are free and accessible, but workflows are not widely available yet. And until a refreshable tactile display is available to consumers, Chancey mentioned that there are 2 kind of on the way. The only other option is printing on microcapsule paper to review the output. And as we've said many times, it takes a lot of time and it's very expensive paper. One of the library volunteers, Marco Salsiccia, did develop a non-visual SVG workflow, and you can check it out at blindsvg.com. I know the organizers will be sharing some links as well. With that, I will hand it over to Chancey to close us out.
So what I want to leave you with this evening is a provocation to think about why graphics matter and how much they matter. I am a child of the early 80s. I'm in the Oregon Trail generation. And I remember going online for the very first time and being able to read information for myself as a blind person and how exciting that was. And then I remember all the other times when I couldn't read content online because it didn't conform to web content accessibility guidelines. And that's probably like a big driver of why I'm in this career as a tech educator, because I want people to get that access. And I think that as a society, it is a dangerous thing to claim to speak for all blind people, and I won't do it. But I think a lot of us reflexively understand at this point that yes, we have a right to an accessible web. Yes, we have a right to accessible textbooks and leisure books. Yes, we have a right to accessible document collaboration tools. We know that accessibility is imperfect, but when it goes wrong, we're quite vocal. And that leads to accessibility getting better over time. I don't think that the average blind person has that same bone deep reflexive level of belief in a right to and the likelihood of getting accessible graphics. For me, growing up, most of the graphics that I saw were related to standardized testing and textbooks because that's where a lot of the regulation and requirement is. And as an adult, really, I didn't experience many tactile graphics. And many folks may lose access to their spatial thinking and spatial expression and cognition abilities and side when they don't have daily access to tactile graphics. And so we're in this pernicious circle where it seems like there's not very much demand because there's not very much access, and you need access in order to get excited enough to demand what modern day equipment is capable of providing. And so I'd like you to take a minute to think about what graphics mean in your life, not just as a developer or a designer, but in your whole life. Are you at home putting together Lego sets with your kids or on your own? Are you drawing floor plans? Are you creating maps maybe for events, for exhibit halls? Are you putting something together from IKEA? Are you playing a spatial game? Are you drawing to entertain yourself or others? Are you looking feverishly at electoral maps way too often? Graphics provide a level of precision that you really don't always get with words. And they do it in a format that is way more concise than the paragraphs or sometimes pages it would take to unpack a complex graphic. Graphics are possible for blind people, but we live in a state of avoidable image poverty because we're not provided with tactile graphics and tactile graphics means of production on a regular basis. We are relegated to a parallel text-only world, but it doesn't have to be that way. So I invite you to join us to embrace the proposition that we don't live in a text-only world, that images matter, that images are for everyone, and that graphics are something that we can engage in as explorers and creators together. Thank you.
Excellent. Thank you very much, Lauren and Chancey. That was an amazing talk. It's certainly an area that I've not explored myself, and probably many others haven't explored recently. And it was just fascinating to learn about the technologies used, how you had to effectively hack, available tools so that it doesn't end up being something that costs like $20,000. I always find it's a real shame that these tools are so specialized and have such a huge price tag. I mean, we already for years already talked about the cost of things like certain commercial screen readers, for instance, and how that just immediately puts an initial barrier of entry for these, to people for these activities, which is a real shame. Lee, have we got any questions at all?
I haven't seen any questions just yet, but I think, at least for me, as for you, Patrick, this was quite an inspiring talk, and I think there are threads we could pull at. I will also say some of the tools that you shared are new to me, and I'm sure many of the other people watching, and they're really exciting as Chancey, as much as you said that the idea of having access to something tactile every day is not a standard, and we want it to be a standard. I think for a lot of people, it's not even known that there are possibilities out there. So this really opens up that dialogue and says, hey, there are tools, there are things. The one example of the kind of $50 sketchboard was so great. The thing that strikes me is how particularly honest this project was about co-design, and not that idea of I'm designing something for you, help, give me what I need to do that, right? So I think there are two things that stood out to me as this idea of there's this suite of tools, but really it's not up to sighted or a blind designer as well to say this is the right tool for the project. It's about getting people together and really exploring the possibilities together, right?
Yeah, I think that's right. And one thing that's been really exciting for me that I was surprised by, I really focus on technical solutions because I'm a tech educator. But one of the biggest revelations for me has been that when you hand somebody, if you don't have the sensational blackboard, even a silicone surface and a ballpoint pen and paper, how much excitement and joy there is the first time somebody does their own drawing or gets a drawing from their kid or their parent or their spouse, and just the spark that lights. And so we can't all have the budget to have a lot of tactile graphics equipment. We can all ask our libraries to hold on to it. We can all ask community centers to have it. I think there are places that people can sort of orbit around to have it. But anybody at any level can just go ahead and pick this up as a practice. You need a semi-soft surface like silicone, you need paper, you need a pen, and that's it. You can just start iterating. And if you are like me, if you're a person who's blind without a drawing background, because my teachers didn't know about this, you can start growing your drawing proficiency and your image exploration and literacy really without spending a lot of money at all.
Yeah, I think you've kind of started to answer a question that came in from Melissa around which of these tools would you recommend for individual use, not necessarily for a job, but for fun. And you mentioned silicone. I don't know if you have other suggestions, but I wanted to ask a question about silicone. I theoretically in my head have a sense of what that is, but where would I get that? Is it an arts and crafts store? Is there a particular format for it that and how you apply yourself with it with a pen or a tool or something like that?
I would go with just a silicone placemat. They have them on Walmart. They have them on all the big shops that you might be thinking of. And really that's it. You put regular paper on top of it and you draw firmly with a ballpoint pen, and it's going to raise a tactile line by creating just the right amount of resistance. Now, for individuals that are on their own, I think one thing that we can do as individuals, if we have a vocational rehabilitation case, which means we have a state agency that's helping us out with our academic goals or vocational goals, we can ask for a Braille embosser as part of the package of computer equipment that a state agency can provide. And I'm noticing a few more people doing that than they were a few years ago. And it takes a really good justification letter that goes to your agency counselor explaining how you're going to use it, because it's going to seem novel to them. But if anybody out there needs help writing a justification letter, that just brings me joy. Causing state agencies to get embossers for people, it can be done. I've seen it done.
That's great. Thank you for sharing that. wanted to pull at this kind of other thread here. Just curious if you can share a little bit more. You said you were really excited about the blind forensic camp and having being able to connect with fingerprints in a more tactile way. Is there more that you can share about that process and that experience as well?
So I can tell you that we took some ink blots, which are, I think, natively sort of grayscale. So they were readily scaled way up to 8.5 by 11 and turned into tactile graphics. I am going to protect the privacy of the patron, and somewhere just know that there was a camp full of blind youth who may be providing us with CSI blind edition sometime in the future when they go into forensics as adults.
Amazing. And it's amazing that you've kind of created this space within New York City and within the location where you are in the library. Do you know if this is kind of proliferating anywhere else? Have you been able to connect with anybody else doing something similar across the US or across the globe?
To my knowledge, nobody is doing exactly this, but there are a lot of cool blind and sighted people doing great stuff. So if you go to betactile.com, there's a couple in Colombia, John and Mafe, that are running an online tactile drawing club for youth and adults in Colombia. Anne over at sensationalbooks.com is making blackboards. My colleague Min Ha, who does a lot of this work with us, is collating tactile coloring pages. Kai Lee up in Toronto is doing accessible Lego diagrams. There's a lot of movement. Accessorigami.com, she's posting accessible origami instructions, which is in the same kind of universe of things. There really is a pretty broad-based movement to get blind people doing, quote unquote, what we thought were visual arts. And everybody has their own approach and their own contribution, and we always need more.
Amen.
Is there something, Chancey, I'm wondering if let's say we can kind of proliferate some of these tools and as individuals we have access and we can create some things or invest in some things that we want to use within our communities. Is there anything that you would say, if I'm having a conversation with somebody or if I'm having a business transaction with somebody, what could they hand me that would really excite me about, from your perspective as a blind person in a dialogue or connection with somebody?
I think when someone gets to see a tactile map or a tactile floor plan and understand that a blind person could use it to independently navigate through an exhibit hall or a conference center or something like that, that can be really compelling. I think that even the concept of embossing Braille on demand is pretty novel to a lot of folks, and just showing someone how easy it is to make a diner menu or a playbill. And I think just taking someone from zero to drawing in 10 or 15 minutes, it's possible to find a pre-existing minimalist drawing online, something that's already a line drawing that's uncluttered, get it over to an embosser really quick, and just give someone the experience that it doesn't always take that long and that it's easier to learn. There's a lot of nuance, there's a lot of craft, but getting started itself is not hard to do. The barrier to entry is pretty darn low.
Yeah, it's very exciting, and really appreciate the prompt and push to say, hey, let's do more of this fantastic stuff. I'll pull at one other thread here of within the project that you shared here, you were creating symbols effectively for something that has never existed before, so they were unique. And then there were other examples we've discussed about kind of some best practices on sizing and standards like that. Do you know if someone was to say, hey, I'd like to kind of take the time to look at this idea of a tactile map for my space or tactile floor plan, are there specific standards within that type of project that exist that are out there to people to follow as far as sizing and line widths and things like that, and what elements to have or not have?
There are some. You can check out Benetech, Benetech Diagram Center. You can check out Pathway to Literacy, which has a lot of articles about tactile graphics. National Federation of the Blind's Future Reflections publication had a special issue a couple years ago on tactile graphics. That's a wonderful read. And then if you head over to brailleauthority.org, the Braille Authority of North America does have extensive tactile graphic standards. I will give you the caveat that those are really targeting K-12 and post-secondary textbooks. So they may be a lot better at telling you how to make a scatter plot than they will be at telling you how to, for example, interpret an art piece. So read them, learn them, experiment with them, sometimes break them.
That's great. Thank you. I will hand it back to Patrick here.
Thank you. And yeah, thank you for the really deep and insightful QA as well, both Lee and our presenters, Lauren and Chancey. To the audience at home, if you like this session, you can hit that YouTube like button. And don't forget, you can subscribe to our channel to be kept in the loop on our future events. Inclusive Design 24 is brought to you with thanks to our supporters, Barrier Break, Intopia, Infoaxia, Tetralogical, Intuit, Adrian Rosselli LLC, Assistive Labs, the Law Office of Laney Feingold, Skyscanner, Vispero. And Inclusive Design 24 will be back on the hour with our next session. So hopefully see you then. And thank you again.
Thank you.